Yep, this is hello. Maybe minus 15. Okay, so yeah. All right, so let's do this. It's August 8th. So yesterday was this, and we tried at the end, and Dijkstra doesn't work. It's too slow, which means my only option now for this one is to go back to the tutorial and understand why it doesn't work, and to see how it's supposed to work. Actually, it looks pretty simple, right? So maybe it's not that bad, but we'll see. Let's do today. Soup servings. 2 soups A and B, each starting with n milliliter. On every turn, one of the following 4 serving options is chosen at random, each with probability 0.25, independent of all previous turns. Okay, there is no operation that pulls 0 from A and 100 from B. The amount from A and B are pulled simultaneously during each turn, which means like things like this is no change. If an operation asks you to pull more than you have left, pull all that remains. The process stops immediately after any turn in which one of the soup is used up. Return the probability that A is used up before B, plus half the probability that both soups are used up in the same turn. Return the probability that A is used up before B. A is used up before B, plus half the probability that both soups are used up in the same turn. What do you mean by both used up in the same turn? Wait, hold on. You're not pulling from A to B. You're pulling them out. If we perform either of the first 2 serving options, soup A will become empty first. If we perform the third option, A and B will become empty at the same time. If we perform the fourth option, B will become empty first. So the total probability of A becoming empty first plus half the probability that A and B become empty at the same time is the probability that, so we have 2, right? And then, so the first 2 is A finish first. The third is they finish at the same time, but we take half of it. And then the end. Okay. So now we have 100. If we perform the first serving option, soup A will become empty first. If we perform the second option, A will become empty. So it's like DP, right? So you have 4 options, right? So you say I take a first if I take the first one, what's the probability and the remaining? And if I take the second one, what's the probability of the remaining? Probability. Or I should say, how many different I would say what's the total number of moves? What's the total number of moves? If we perform the second serving, 75, A will become empty on performing 1, 2, 3. And both A and B empty will be performing 4. But this is 10 to the 9th. I can say, yeah, if I take the first, what's the remainder? Right, I have remainder. So A is this. Oh. If I take the first, okay, now I have A and B. And if we use A and B as a state, so we can ask how many ways that A and B can lead to A end of first. How many we can get them to be equal. And then you have this, you add this, you add this, you add this, you add 4 of them, then you have the total number of ways that A can, right, board. What's the total number of ways? I don't even know the total number of ways. So in this case, I have basically this for A to go first, right? And then I have this times times 3, because I have these, plus yeah, that's 2 times 0.25, and the last one is just 0.25. This is A to go first. Now we need A and B is the same, so it's times 25, that's this, right, and then plus this, okay, so I'm doing this plus all of this divided by 2. So that's just 16 times 3 divided by 2 is 32, right? This one is this plus this plus this plus this. No, I think this is times 0.25 because you have operation 2, so times this. So yeah, so this is this plus 16.3, 16.2, and 16.1. 7. 7 plus 11 plus this. So what's that? 11, 16, 3, 32. 7, 8, 1, 1, 7, 8, 1, 2, 5. Yep. Oh, wait, hold on, no. Oh. Wow. I think we calculated not right. Huh? Did I compute this one wrong? Oh, should be 10. My bad. There we go. So yeah, we got the idea, but how do we compute this? So it's the equivalent is how many different ways we can add these numbers up to become 100, to become n, while the other one does not become n. All right. So if we keep doing this, yeah, we're always going to be getting equal amount. Right, well, now we're always getting more A than B. But every time we take one of this, so like as long as we don't always do this, any combinations will work. Then how do we handle the probability side? Yeah, if they want to end up the same, so you can either do all this or do alternating this, or do this plus this, right? Oh, probability. All right, no idea. Let's see. Oh, this one doesn't even have a hint. I don't remember how this one's done. All right. Okay, that's fine. We start with I servings of soup A and J servings of soup B. Wait, I servings of soup A and J servings of soup B. I servings of soup A and J servings of soup B. When we have I servings of soup A and J servings of soup B left, right? That's what dpij means. So if I is equal to 0, any value of j will become 1. Correct. If I is larger than 0, j is equal to 0. Be empty first. We don't allow that. That will be 0. If both are 0, that means soup ran out. I will do half. That is correct. The recurrence relationship. Consider an example. Have 7 servants of one and 4 servants of the other. So now we have a transition, right? So we have 4 different transitions to this, and this. Thus, this will equal to the probability of this will equal to the probability of this plus this plus this. That's correct. Now we write down the recurrence relationship. At each state, we have 4 options with an equal probability. If we choose the first operation, we will decrease the amount of soup A by 4. After that, we'll be in a state of this, and then this. The max in the transitions prevents negative. Okay, so this will equal to this. I agree. denote the initial amount of servants. The answer to the problem is this. Wait a second. The answer to the problem is dpmm, initial amount of servants, minus the initial amount of both. I don't think this is minus. I think this is just to now minus the initial amount of both types of soup is m servants. I don't understand this sentence. I mean, I understand this DP process, but this process, the initial amount of both types of soup is m servants. I don't understand. What do you mean by initial amount? Is it converged to 1? Yeah, that's what I thought. It converges to 1. I think it just converges. On average. Yeah. Okay, we get the M. This is the DP. What the hell is this? This is the DP transition. We can try to implement it. Maybe read through it. I didn't think of dp because the constraint immediately made me made me ditch dp as a potential method. What I didn't expect is that the answer converges to 1 very quickly. Hence, dp is still a valid solution. The transition, like the dp itself, is not complicated. Okay. It's not that complicated. dp ij, the ideal of using servants is actually quite brilliant. Is the probability, right? Is the result probability when there are I servants of A and J servants of B left. Thus, dp 0 J, where J is not equal to, where J is larger than 0, is always 1. dp I 0, where I larger than 0 is always 0, and dp 0 0 is 1 2, as both are empty, and we take half the probability. For transition, dpij shall equal to 1/4 of dp I minus 4 j plus dp I minus 3 j minus 1 plus dp I minus 2 j minus 2 plus dp I minus 1 j minus 3. Okay, so if we want to do it, So dp00 is equal to 1 divided by 2. 0.5. Right, that's 0, 0. And then we're starting from 1, and the other one also starting from say I is 1, I is smaller equal to n, I plus plus, okay. So we can say dp0, no, I0 equal to 0. Which is fine, because we define it as going to be 0. But no, just yeah, just do this, right? And then what we're gonna do is we're gonna go j 0 j smaller equal to n, j plus plus, right? Now for each one, say dpi j, no, dp 0j equal to 1.0. Prefill, right? Prefill. And then what do? We basically go through everything. No, we don't go through. I think here we just go through. I think we should go through to I. Right, we just fill up to this, and then yeah, fill up to this, fill up to this, yeah. And then you can say dpij, right, shall equal to no 1 divided by 4 times dp maximum I minus 4 j, right? J minus 1. Oh, j cannot be minus 1. Okay. I minus 2. Last one. Actually, I don't need this one because I is equal to 1, so I can do I minus 1. Okay. So we do that. Right, we do that. And then once it's done, yes, we say if dpii minus 1 is smaller than 1e negative 5, then we'll return 1.0, right? So this is convergence. Otherwise, we'll finish everything and I'll return dp n. Okay, something like that. Oh, it does not make sense. Something is seriously wrong. Okay, so this is not right. Maybe this has to be starting from 1. Yeah, I think it should start from 1. That is very wrong. I think maybe it should be like this. It's approaching 1, but it doesn't reach 1. This one's right, and this one's wrong. Alright, I don't know which part I didn't do right. Oh, I did a lot of things now, right? I have to do ij and ji. Huh. I have to do both. Okay, so I think what it means is I need to do 0i. I don't have to do 0i because it's already been done. So I don't have to do this again here, but I have to do this one more time. So we do ij, but I also need to do ji. This is the other way around. Okay, this is something I did not expect. I think even if you figured out the convergent, this one still you cannot figure out. Because on both sides, that's on both sides. You have to do ij and you have to do ji. I don't know why you need to do ji. Because you want to fill out every possibility, right? You want to fill out every possibility. And as you go through, you do have to fill out all the possibility. But why would it work? I is something, J is something, right? And then basically we're saying, well, fill up every single thing. So there will be overlaps. Right? There will be overlaps. No. No, we just handle the other side of the story as well. Yeah, because this supposedly this should reach n, right? This should reach n, then we can cover everything. But we just ahead of time handle it. I'm not able to solve this. N equal to 1. Huh? Oh, shoot. Wait, hold on. This is right. N equal to 1. This is 0. So I return 0, 0. N is 0, so this one doesn't even go through. Wait, what the hell? I take 1 serving. Where did we go wrong? Oh, maybe that's the one. Yep, that's the one. That's the reason. Nah, whatever. I see how that come last time. All right. Yeah, it is what it is. It is what it is. Yeah, it's all right. It's all right. Problem. It's a little bit brain teaser for sure. All right, that would be it. This is. I mean, I probably can come up with this, but I think there are several hurdles, right? For one, this is kind of out of. I don't know how they come up with this. You just swap it, so you don't have to go all the way to the end. I don't know. This looks very smart. So you fill up on the other side. Fill up on the other side. Because if you don't do that, you only have half. Right, because at the end we want to do II. So if we want to do II, so you have to compute all the other side as well. So now that's why you need to do it. All right, anyway, yeah, I'll see you guys tomorrow. Adios.